Hey there, my name's Thomas Weeks, aka Tweaks, here at the Cyber Range. I'm giving this video part one of demonstrations of shared networks and OPNsense Firewall environments. Here is basically a new product we rolled out here at the Cyber Range, and wanted to step teachers through this because it's very different, and showing teachers how to use it effectively in a classroom environment I think is really important. Before we roll these new environments out. So first of all, part one, we're gonna go over what is shared networks environment. Um, there's going to be several of these coming out, but the first one is a larger OPNsense environment, and the smaller one is a single VM Kali shared network environment. We're going to go over sharing network, how to use shared networks to in the classroom effectively, what it looks like, what it feels like, how to interact with your other students' VMs, and how they can interact with yours. And then we're going to talk about a more advanced multi-teaming firewalling environment using OPNsense firewalls. And then as soon as you get into multiple VMs per team, we have more complex DNS naming structures. You can see a hint of that over to the right, kali.alpha099.example.com. Basically, class 4 unique DNS host names for the entire classroom. And then what using a multi-team shared networks environment in class actually looks like, and how you interact with students and keep yourself safe and keep them working well. So a shared network environment is basically an environment in which you can connect the walls or connect the networks, tear down the walls between your student VMs and yourself and each other. So in a normal environment, when you first roll it out, in fact, it acts just like a normal environment except for the DNS names, where each student VM and their own little network bubble can get out to the proxied web service to get out to the internet, but not much else. So they can't get to each other. They can't ping you. You can't ping them. You'll notice one other thing that's different is the host name. So we alluded to this already. For example, if there's a kali.example.com in the old days, now it's kali.teamname.example.com. So in this case, alpha099.example.com is that first team on the left, and delta022.example.com is the team on the right. And each host in their network has its own unique host name. So with inter-team connectivity is the feature that you can toggle on and off to turn on the networking between you and all your students' VMs. So you do this with the toggle inter-team connectivity button. I think I have this up in my UI here. Pull this up. So here I am logged into the Cyber Range, and this is a more complex network environment with multiple VMs per student team environment. But the button is right here, toggle inter-team connectivity. So as soon as you turn this on, it'll turn on the network between all the VMs in the classroom. It acts kind of like a switch. So where before it was like they were all each on their own network or their own VLAN, if you will, as soon as you turn that on, it acts like a switch between all the classroom machines, including your own. So they'll be able to see you, you'll be able to see them if you haven't taken any precautions. So this is the biggest thing, is what shared networks and networks environments are all about. So being able to turn that on and off, and it's nice because you can for example, give them some assignment and say, okay, at noon I'm going to scan the network, and everyone should have a web server up or a MySQL server up or whatever. It's pretty handy. Now the potential downside, if we just rolled it out as is now students can scan and log into each other. So that's really cool. That's really great for teaching offensive security, defensive security, red team, blue team. But what happens in the classroom when suddenly students can all log into each other's systems as student, for example? So if your students could all log into each other's systems, including yours, and you're teaching a class, how smoothly do you think your class would go? If you haven't done this before, I've done this. It's really chaotic. There's pranksters in every group, people that are DDing over people's hard drives, shutting them down, powering them off, doing destructive things, playing rude, obnoxious sounds, throwing rude, obnoxious graphics on the overhead projector. So you don't want that. That's chaos. So with great power comes checks and balances, basically. So with an open network like this, the default student passwords need to each be unique. And that introduced a little bit of complexities, but we have a really great way of handling that now so that students can still log into their stuff and not have to type in big, long, complex passwords. It just works really easily. And you can get to their work also. You can get to their VMs very easily and log in to their systems as them to check things out. So the per VM unique passwords feature is something that we added along with shared networks. So now a student would just click on show me my environment login credentials, and it pops up a little browser or a little pop-up in their browser to give them their credentials. It shows the student username in clear text, but the password it obscures. You can click show to expand it, or click on the copy button just to copy it, and I'll show you that here. I can go down here to student Team Tweaks 2 on domain Foxtrot 980 and click on his credentials. Well, I click on my own credentials here. Each student will get this view. Click on my credentials, and I can get to all my systems. Here's my student login and password for each one of my systems. I want to say, for example, server 2. I could say show me what the password is. They're fairly long passwords, but more importantly, they can just click copy, which is what most students are going to want to do to be able to log into their systems. Likewise, you can do the same thing down here. Go down to whatever student you want to log into as the instructor, click on the credentials icon, and copy whatever you need to get their firewall or their desktop system, and copies it to their buffer, and you're good to go. So it's really handy. You need to learn to rely on that if you're going to interact with your students' systems. But more importantly, it keeps the students safe from each other and you safe from the students. So very important. I just went through the instructor view. That's kind of what it looks like. Clicking on those pops it up. This was for a single desktop system versus the one I just showed you, which would have multiple VMs within each environment. So using a shared network environment, it's really great for teaching everything from network port scanning between students to providing classroom-wide targets for students to hack on and scan against, as well as studying things like endpoint defense, things like network security hardening, network service security hardening, OS patching and scanning, endpoint firewalling, using things like IP tables or UFW, as well as server and web application security. So having them set up an Apache server and then harden it, for example, or install WordPress and harden it. That's quite a task, but that's very much that's resume material there. So that's really good stuff. So you can also teach live instructor classroom scanning labs, and we're going to show a little bit of that later. Have these students make some adjustments to their firewalls, and then we'll do a live scans and see what that looks like, as well as kind of ready, set, go, red versus blue environments. So say, okay, you all have until noon to install a LAMP, Linux Apache MySQL set up on your systems, install WordPress, harden it, and then at noon I'm going to enable interteam connectivity and go. So you'll have to defend and attack others at the same time, or you could just do just basically blue team. So you can tell them set up your system and set it up for to harden the application, WordPress, for example, and then I will come through and scan for vulnerabilities, that type of thing. So the red team, blue team, we'll get into more of that later. That's more advanced. So speaking of the more advanced setups, this is kind of what something like that might look like. This is the OPNsense environment, where this previous environment, this one actually doesn't exist yet at the time of this writing. This is basically just a simple Kali system. I think this one's going to be very, very popular because it's rather entry level. But for the more like community college, university level type environments, you're going to want to start teaching, more advanced firewalling, networking, red versus blue real-time attack and defense simultaneous. The nice thing is with these, you can have multiple students in this environment. You can put one student on the desktop system to harden it, and then on this network down here have two students set up services, and another student working on the firewall. So you can have multi-student teams. You can do network traffic monitoring. You can actually run things like TCP dump from the OPNsense Firewall and capture man-in-the-middle type content, doing offensive security, scanning other people, doing penetration testing, intrusion detection, and intrusion prevention on these hosts. So all kinds of really cool stuff you can do with this type of environment. And this is where this team name becomes very important. So the team domain name is kind of like the not the prefix, but the postfix to the host name. So we'll look at that in just a second for how that works with each individual host name. So the ability to toggle on the inter-team connectivity is what turns on this kind of the WAN interface on the firewalls ability to connect to other networks. So this is something we do at the software-defined networking layer, but once we turn that on, all systems can see all systems. So normally your class would start off with there's no connectivity at all. Inter-team connectivity is disabled, and they can't see each other. And you can actually use that just to teach basic host security and firewall rules, and then when they get more advanced, okay, now we're going to start scanning each other, or I'm going to scan you, and get into more of that red versus blue attack defense type scenarios. So the way that the naming works, their team name is the team host name, or I'm sorry, the team domain is the name assigned to the external interface of the firewall. So you have the firewall here that would normally be connected to the WAN. If I hit foxtrot980.example.com, if I ping that, I'm going to be pinging the external interface on their firewall. So that's very important here. That's one of the main things you need to remember when working with these more advanced multi-host, multi-network type of shared network environments. So you have the external interface, the name that is associated with that interface, the multiple internal networks. Here you see we have a LAN that has called Blue Network 1 with desktop systems in it, and then Blue Network 2 with server systems in it. And this is a really great kind of enterprise type environment you would set up to teach students how to secure an enterprise and separate your desktop users from your server users, how to configure the firewall, how to set up DMZs, things like that. And on the firewall side, if you hadn't heard of OPNsense, it's a kind of a fork of PFSense, which is a firewall built on top of BSD. Really, really great system. We've been working with the OPNsense guys on their Amazon image, and we love it. It's really, really great. Super powerful. It's the kind of thing you'll see in enterprise type firewall environments. It is stateful packet with inspection rules, stateful packet inspection with individual rules per interface. So interface-based traffic routing and rules, admin shell for doing configs and backups. And you could do really cool things like drop to a shell and run man in the middle, TCP dump sniffing, things like that. So very, very powerful. Other things you can teach, you can also teach, basic OS hardening, intro to firewalling, network monitoring, headless servers. For example, I've got a lab I'm writing right now where they're setting up an Apache server on server 1, a MySQL server on server 2, connecting the two, and then securing it from the internet. So it's only accessible over port 80 and 443, for example, as opposed to seeing my database server, things like that. So that's what I'm talking about, web application security and installing WAF, web application firewalls on your application servers, things like that. Implementing a DMZ, really important stuff. So if you're going to expose a web server to the internet, you want to make sure that can't be a hack and pivot points where people can get in there and then pivot to your internal network or pivot to other servers or other systems. Really important concepts. And of course, then red versus blue CTF competition. So capture the flag, using this environment to capture the flags and attack other people's systems and get the flags and harvest them for points. And we've got some stuff we're working on right now that possibly automate some of that stuff too. So really, really cool stuff coming up. And then the way these DNS host names work, though, to dig a little bit deeper. So we already talked about how each team has its unique domain name here. So the external interface has that domain as its external interface. So if I ping foxtrot.980.example.com, I'm going to get the external WAN interface of the firewall. Now the internal interface on the firewall has its own unique host name also. It's firewall.foxtrot980.example.com. A little bit longer than just just example.com, but this is very important if you're going to be doing kind of a real world classroom environment settings where they're not going out to the internet, but they can see the entire classroom. So the entire classroom becomes kind of the internet. So really, really cool. And then of course over in Blue Network 1 is our desktop system. So that's going to be desktop.foxtrot980.example.com. And then server 1 and server 2 .foxtrot980.example.com. So that's kind of the naming structure and how it's set up to work. Each student will get their own domain. Now, to be able to use this functionally, imagine this in a classroom environment where you've got, okay, I've got 20 students and they each have, 4 or 5 host names. That gets pretty squirrely. And to be able to use it effectively as a teacher, you need to be able to scan these things in an intelligent manner. So we saw the need, and I had our DevOps guys create a little service where you as the teacher can download all the host names of all the students' teams in the classroom. So you just do that by going to the instructor view, clicking on export DNS records, and that gives you a CSV spreadsheet with all of the teams, their domains, and their desktop systems. So without this information, students cannot easily discover and scan each other. They could scan each other's IP addresses or just scan the WAN for IPs, but they're not going to know the internal host names and not be able to reach those without some more information. So you can provide this to your students at a certain point in your labs and exercises, or keep this secret and only use it yourself. I'll show how that works in just a moment. In fact, I'll go ahead and flip over to here and go ahead and click export DNS records. I click on that, and it's going to pull it up into a basic, whatever your Office suite is. I'm running Linux, so this is a LibreOffice. So now I've got access to all my classrooms, desktop systems, server 1, server 2, and firewall names. So I can use this in the classroom really easily. Excuse me. Use this really easy in the classroom environment to start doing scans and checking student progress on things. So I copied out, let's see, I'm going to do the desktop systems. So I copied these out of the spreadsheet, and I think I pasted them over here into a non-rich text, like notepad type thing over here. So my system here, I'm the teacher, instructor, I'm on Papa. So Papa 776, so that's me. I want to scan the other desktops in the classroom. Let's go ahead and do that as an example. Let's see. Yeah, so this is my environment here. So I'm the teacher over here, and I've got a student, Foxtrot, over here. So I'm going to go ahead and set up a little scanning script, and we can see how inter-team connectivity works functionally. So let's go over here to my classroom. There's my classroom. I'm going to go ahead and close out my VMs and open up my instructor VM. So here's my instructor VM desktop. I'm going to go ahead and open up one over to Foxtrot also. In fact, I'm going to open up one to each, just for the heck of it. You see how I just access these real quick. Auto login is enabled, so I don't have to worry about the passwords if I'm logging into my own environment, or as the instructor, I can log into any environments without passwords because I've got that built into my interface. So I'm not sure which one is which right now because I've pulled them all up so quickly, but if I pull up in the terminal, it'll tell me the host names. We modified these systems so they show you the full host name in the terminal, so it's really nice. Here we see this is the desktop of Foxtrot, so that's the student I'm going to be working with. This is another student, X-Ray, and then my system is Papa 776, so this is my firewall here. So I'm probably going to be doing some scanning from my network. So I'm going to increase the size of this a little bit. And right now I'm just going to show basic ping. So I'm going to go over here, and I'm going to ping Mr. Foxtrot desktop system. Control-C, Control-Shift-C from the terminal. And then ping. This shouldn't work right now because it's by default inter-team connectivity is turned off. So yeah, it does not work. But if I go in to here and toggle inter-team connectivity, turn that on, then I should see this start to ping. There we go. So now I'm basically pinging, and now the entire classroom can see each other. So this is not insignificant. You need to keep this in mind that once they can see each other, they're going to start pounding each other. So in this environment, you typically don't have to worry. ICMP pinging on the firewalls is enabled system-wide, so anyone can ping anything in anyone else's network. So yeah, they could send ping floods or ping attacks, but that's about all. They can't really touch any of the ports or TCP connections on these systems. So right now ping is open, for example, but if I were to do an nmap scan of that desktop system, I'm probably going to get nothing because the firewall rules are fairly tight. It's a lockdown. It allows ICMP but not any TCP port connections. So I'm good to go there. So it's still secure. But say for example I wanted to set this up, so I'm going to tell the entire class I want you to set up firewall settings to allow me in to see your networks. Let's go ahead and log into let's have Foxtrot, for example. Okay, so my ping failed, or my nmap scan, but ping works. So let's go ahead and just to give you an example. So if I want to ping, for example, I think I've got a for statement I wrote here. So for I n, and this is really simple stuff. This is not bad. I recommend, if you've never done this before, to take this away. This is very useful. This is a good way of doing scans. Control Shift V, that's paste. Say do a do, and then I can say ping count $1 $I. I think that'll do it. And so this will ping each host in my classroom once, which is useful. I can say I can ping everybody right now. Now, if I'm monitoring a classroom, for example, I might do this as a watch script, so it's running constantly. I think I need to escape this. Escape that. And I forgot to escape this one. I should always practice this stuff beforehand. Here we go. So now I'm pinging my entire classroom, and I can see each student's system. So if one student shut his system down or hasn't started, I'll see it here through 100% packet loss, basically. So here's just a quick example of how you can see your students in real time. So really handy, very powerful stuff. We're going to do the same thing with port mapping here in a moment. Let's go ahead and do that. Go over here to Foxtrot. Now let's see how to log into the firewall. You would think that you would get access to a firewall by clicking here and logging into the firewall. That's not really the way OPNsense works. So SSH is kind of a back door. If things go wrong, if you lock yourself out on a firewall, which happens a lot, that's a great way of learning, is mess something up, right? So if you mess something up and you lock yourself out of the firewall, the SSH method is the backdoor method for getting in. Excuse me. So let me log in real quick. So here's my kind of backdoor into Foxtrot's firewall. So this throws you into a BSD SSH session. It's just a normal shell, but just like in the real pfSense and OPNsense, you only get the firewall menu from the root prompt. And so we of course access that from sudo su, and then that will throw us into the firewall prompt here. And you'll see from here we can drop to a root shell if we want to, but the most important thing here is if you mess up your firewall, or a student locks himself out of his own firewall, you can go and do a restore from backup. So option 13, and say here are the different snapshots, or the last changes. Every time you make a change, it's snapshots. So here's the last change I made that may have screwed things up, so I'm going to restore to that setting. If I don't want to do that, I can just break out of it. So that's an important concept. You need to know it, but we're not going to get too deep into the SSH. the reason I want to show that to you is because to log into Foxtrot's, and the student needs to do this themselves, to log into the Foxtrot firewall, they need to go to their credentials for SSH. And they can click show or just copy. I'm just going to copy. And I'm going to go into my Foxtrot desktop because this is a web UI. You can't get to it from this SSH login. You need to log into a system with a desktop on it and a browser. So this is the web UI, so I'm going to bring open the Firefox browser on the Foxtrot's system. And I'm going to say, let's get my domain name because I'm going to go to firewall.foxtrot. Control-Shift-C. Firewall. It's already there, so look at that. So this is the main web UI login for the firewall. No one can get this from the outside. This is only from the inside of their network. So it can only log in from here. It's logging in from here to here. So can't get to that interface, that port 80, port 443 traffic from anywhere else, just only in this interface. That's how these systems are configured. Now if they hack their desktop, they can reach it, but they still don't have access to their password. So hopefully that's semi-secure. Let's go ahead and log in. It's student, it's not admin. I always mistakenly type admin there because all my home firewalls are like that. And then I'm going to pretend like the password's not there and go over here and say, okay, give me make sure this is Foxtrot credentials, firewall, copy. And I'm going to paste it right here. All right, and so there's a lot to take in this this firewall interface, but most of the stuff we're going to be doing teaching firewalling is just here in the firewall. I don't recommend messing with a lot of the other stuff. You can really hose the system pretty bad if you start messing with the interfaces and things like that. VPN. There's some cool reporting things you can do though. Looking at net flow settings, traffic, live traffic. Some of the live traffic stuff they're doing now is really, really cool. But I'm going to go to the firewall tab and rules. So we're not going to mess with nets or automation or NAT or automation. We're just going to click on rules. This is most of what we're going to be doing. So, and you'll notice if we look at the rules, the way the rules are laid out, this is very distracting. Let me click on this. It's sorted by interface. So I'm going to go ahead and expand this out a little bit. So it's shown by interface. So this is the WAN interface, which is here on the firewall. And then I have Blue Network 1, Blue Network 2, here, and here. And so this is the place the traffic is coming from, is how these rules apply. And if you've never done firewall rules or ACLs, access control lists, or IP tables, that kind of thing before, it's a stateful inspection, first match. So it flows from top to bottom, and first match applies. So if you've got an allow all, for example, I've got an allow all on ICMP, so anyone can ping from anywhere to anywhere. Yeah, so that's what's allowing. If I want to disable that, I can totally turn that off. You'll see the little key down here. So green means it's enabled. Gray means it's disabled. And if I, for example, right now I'm pinging, I think I'm pinging over here. Where's my little loop? So I'm pinging Foxtrot. So I'm seeing, here's the time in milliseconds on that ping. If I go back over here and say disable that, I can click disable. It doesn't apply immediately. I have to click apply changes. As soon as I do that, this ping on Foxtrot should start failing. It takes a second because it has to time out, I believe. Yeah, it's going to take a little while to time out. You can adjust the timeout delay on ping, by the way, if you so choose. So anyway, that's what that just did. I was prepared to demonstrate this, so there we go. So now, oh, look at that. I'm getting on all of them. That's strange. It's only on Foxtrot. Oh, I'm doing 3 desktops, Foxtrots. Oh, I forgot. Yeah, the way I'm doing this ping is should be doing one at a time. Anyway, so I just disabled that. Let me turn it back on. Ping is Nmap is really good for doing multi-device scans like that. Ping, not so much. Let me apply that changes. Turn that back on. Apply changes. Oh, there you go. Always got to click apply changes. So I'm scanning Foxtrot 3 times here, so that doesn't make much sense. But I'll show how to do some more cool stuff like that later. So getting to this back to this environment. So the firewall has to be adjusted on each one of the interfaces that you intend to interact with or connect things to. So that's the WAN interface. If I want to affect traffic coming from Blue Network 2, so I would click on Blue Network 2, for example. Later on in a later lab, I'm going to show how to install Linux, Apache, MySQL on these servers and lock them down. And I would do that, lock them down, using the adjustments to Blue Network 2. Blue Network 1 is my desktop LAN. So again, if I want to, for example, let's go ahead and have Foxtrot. This was the original example. I want to enable port scanning on Blue Network 1. So my desktop, I'm going to expose my desktop to TCP port connections. So for example, right now, I've got IPv4 coming from the WAN interface. This is important. The traffic's coming from WAN, so we need to go to WAN. Right now, you see nothing is allowed to Blue Network 1. But if I click on that and say, before I click apply, I'm going to go ahead and do a port scan. Let me do a port scan of that system. So Nmap, desktop.foxtrot. I want to do that. Nmap, fairly aggressive, quickly. Do an Nmap of that system. It's going to do a most common ports scan of that system. Right now, it should fail. And if I've assigned the student to open up his network so I can see his, I'll just do all of his hosts. Let's do Blue Network 1 and Blue Network 2. Click apply. I never clicked apply. That makes a difference. So it failed. The previous scan failed. Now if I do desktop and let's do all 3. Server 1, server 2, do that scan. There we go. So now I saw that Foxtrot's desktop system has ports 22 and 3389 open. That's of course SSH and RDP. It's got RDP. It's not Windows system, but it's RDP because this remote desktop is an X11 desktop, but we're exposing it through RDP. So we're actually running XRDP service. That's how we use to connect to these systems on the range. So 3389 port 22, and of course on server 1 and server 2, they're going to be web servers and MySQL servers eventually, but right now they're just running stock Ubuntu server, and they're running just plain old port 22. We could also do, for example, if I wanted to do a service scan, I could say, okay, go ahead and do a fingerprint scan on this system, for example. I need to do this as root, so I'm going to sudo that. So this will do a more intensive scan on that system and tell you what banner versions things are running. You know, the SSH server. If this was running Apache, it would tell you what version of Apache it's running. Here we go. So this told me, okay, this is 22. No exact operating system has been matched, but here's the fingerprint. Okay, well there's some, I can look at the headers to get exact versions of SSH and things like that. But this is a good way of fingerprinting system to try to detect what operating system they're running, things like that. So let's see, I'm going off script a little bit, but that gives you an idea of how to set these up. Now, if you're teaching firewalling, an important concept is being able to have students secure their stuff, but they also need to scan them from outside themselves. So to do that, so for example, if you have the student want to harden his network, harden his operating system, and set up firewall rules, he has to test it from outside the network. You can't test server 1, server 2 from a desktop LAN over here because it's treating it differently than WAN rules. So you have to test it from the outside. So to do that, in this setup here, I've got this student environment Foxtrot, and my system is this Papa domain. I'm going to set that up. I'm going to use my server 2 in this classroom to give all students in my classroom login access to server 2, which is kind of dangerous if you don't know what you're doing. And so that's why, if you're going to do this kind of thing, and in more advanced classes, you need to, first of all, put a DMZ around your desktop network. So don't allow any traffic from Blue Network 2 to Blue Network 1. So we're going to want to do that first. Go ahead and add user accounts to server 2, and then add another rule to allow SSH access in your firewall down to server 2. So let's go ahead and do that real quick. And what that'll do, that'll allow students to get into server 2 and then do the scans they need to do in a secure manner. Now, to make sure that students don't interfere with each other, I recommend having a separate user account for each one of your systems. So for Foxtrot, I'm probably just going to make a user account called Foxtrot and give him a junk password, and he can change it. Same thing for X-Ray and the other students too. This is not something that we do for you, but as a teacher, if you're wanting to teach firewalling, I recommend this because always teach students, to scan from the outside. You can't scan yourself. Some people try to Nmap scan their own host name or themselves. It doesn't work for various obvious reasons. So to do this, we're going to go ahead and I'm going to go over to, this is the Papa system, so that's my system. I'm going to go to papa766example.com for server 2.papa776. So let's go ahead and do that real quick. I'm going to go ahead and go to my Papa system, server 2. Go. So now if I'm user Foxtrot, I can currently ping desktop.papa776. So this is the teacher's instructor machine. I can ping it. I can even try to SSH as student, which is actually the instructor on that system. Okay, that's scary. We want to deny that. So I need to go to my firewall on Papa, bring up the firewall, and again I'm going to be setting up this blocking rule here from Blue Network 2. I'm basically going to make this kind of a DMZ. So fire, there we go. Let me get my password, Papa, server 2, this is the firewall password I'm getting. You can save, by the way, because unless you're worried about them hacking your desktop, then maybe not. I never recommend that, actually. So again, I'm going to be blocking traffic, all traffic from server 2. I'm sorry, Blue Network 2 to Blue Network 1. I could do just server 2 explicitly, but then if they could pivot over here and attack me. So I'm going to do Blue Network 2. I'm going to set this up as a DMZ, kind of. So I'm going to go to Firewall, Rules. Make this a little bit bigger. Firewall, Rules, Blue Network 2. 2. So anything, right now, anything is allowed to anywhere. That's going to apply first. I don't want to allow that traffic coming out of Blue Network 2. So I'm going to modify this rule. From, I could say pass to block. So anything coming from Blue Network 2, you need to look at protocols, IPv4, protocol, any. I'm going to do TCP and UDP, which includes ICMP, by the way. Destination, any. I can give it a single individual target or an entire network. So Blue Network 1. I can get a Blue Network 1 address or network. I want to say anything on my Blue Network 1 network. Ports, any. I want to do all ports. And this is blocking. Looks good. There's some very detailed stuff you can get into in TCP flags and things like that too. Let me go ahead and save that just so I can look at it. Nothing has happened yet because I have not clicked apply changes. So let me go over there. Let me go down to server 2, Papa, and I'm going to start pinging. I'm going to try that SSH again. So SSH is it's allowing me, and I'm going to flip over to here. So anything from Blue Network 2 to Blue Network 1 is blocked. Apply changes. I go back here and attempt to connect again, and it's being denied. Let's see if I'm also blocking ping. Yeah, ping is also being blocked. So that's good. That's what I want. So I just secured my Blue Network 1 from Blue Network 2. Okay. Now I can actually go ahead and make the firewall rule to allow people into my server 2. Now I'm going to want to give explicit IP address only. So from the outside to this device only. If I end up setting up a web server here, I don't want them getting there. Now that's another issue between these systems. There'll need to be some security, but we're not going to get that deep. I'm just showing them some basics. So I'm going to set up a firewall rule. So WAN to this IP address. So let me get the IP address first. IPADDR show. You can also just do a hostname -I to get your IPs. You'll see this 100 net once in a while. That's our service network. So this is this other line in the network diagram that you'll see sometimes coming out of the network to a green blob called our service network. So that's actually where you're already RDPing in from the internet, and that's where we provision our VMs. So that's a separate interface. You can ignore it basically. Ignore the man behind the curtain. This is the IP address of my server 2 here, and you can also look it up, do a host lookup on my host name to verify that. Just to double check. I can type it right. So yeah, 33.54. So that's me. I'm going to go ahead. This is the destination I'm going to allow access to on SSH. Control Shift C. And let's go to the firewall on WAN. This is my Papa firewall. Z Papa 77766. Now I'm going to make a new rule. I don't like all this other stuff that's disabled. This is dangerous. So the unused rules, I don't like leaving them laying around because I'm going to accidentally click on them. So you might want to teach to that. But I'm going to go ahead and create a new rule to allow a fresh rule. Pass IPv4 protocol. I'm only going to do TCP. I don't need UDP or ICMP in this case. It's already there. Protocol source any. So come from anywhere. Destination. I can do this firewall, different networks, or single host. That's what I want. It's important also when you're teaching this, if you're teaching firewalling, they should already know TCP/IP fairly well as subnet masking and CIDR notation. So we do not use 255 VLSM notation anywhere in this firewall. It's all ICMP, or it's all CIDR notation. So if they don't know CIDR notation or how to define, change it from a, class C triple 255, /24 to a /32. If they don't know what that is, then they're not going to be able to do firewalling effectively. So really need to understand CIDR notation before you start teaching firewalling. So this just locks it down to an allow to a single IP address inside my network. That's all that does. From any to any port? No, it's going to do just port 22, just SSH. There we go. SSH from SSH to SSH. That's normally a port range you can do there, but that's what it looks like when you do a single port. Okay, always important to put a description. Allow student SSH access to server 2, because server 2 is not in the name of that IP address, right? We're not doing DNS based. This is IP based, so I need to put the server 2 there to my server 2. All right, schedule all the same. Save it. Take a look at it. Oops, I puked on something. Did it not like? Not a valid destination IP or alias. What did I do wrong? Single host or network /32. Look at that. I got a space in there. That's a really common problem. I'm glad I made that mistake on the video. All right, so that should be good. Port 22. Here we go. This is me. So I'm allowing ICMP up here. So ICMP is going to be allowed through from WAN to anywhere. But specifically, this is going to restrict or allow SSH to this one host in my blue network. Apply changes. All right, now Mr. Foxtrot, here's Foxtrot, should be able to log in as the user Foxtrot at server2.papa. I'm going to grab that one. Fix that, server 2. Let's see, I have nothing up my sleeve. It's the first time I've done this, so I should get an SSH key thing. There we go. Oh, I didn't. I must have done this before. There we go. I'm now on server2.papa776. Now I can scan my own systems. I'm the student Foxtrot here. So I'm here. I SSH'd over to here. Now I can go and do all these cool scans of my own systems. Okay, so I can say, okay, I'm going to go ahead and do an nmap scan of an aggressive one. And I can't do sudo stuff, so I can't do any really fancy stuff because I don't have root access on the system. I could grant sudo access just to nmap, by the way. That's a little bit deeper, but let's go ahead and scan my systems. So I'm going to scan pull this open so it's a little bit easier to manipulate. I like copy paste. I don't trust my own typing, as you can tell. So I'm going to scan my desktop system and my server 1 and my server 2. Okay, so we've gone ahead and set up user accounts over here on server 2 of the Instructor system so that students can log in. We have secured the Blue Network 1 with the desktop system, the Instructor's desktop system that we don't want students messing with while they're over here messing around. And we've set up an incoming SSH rule to allow them to SSH into server 2 by IP address. One last thing I forgot to mention is we need to also enable a rule to let them initiate contact connections going out of the firewall to other networks, so they can come in here and scan their stuff like this. So to get that, we need to go over to the Instructor Papa 766 firewall and look at the Blue Network 2. We need to make an additional firewall rule here, specifically that allows from BlueNet to server 2 to any protocol anywhere, kind of outbound, which to the firewall's perspective is incoming. And I had that backwards, so I want to show that to you. So the action is pass. Interface is going to be Blue Network 2. Direction N, I think I had out and it wasn't working, so I switched that to N. And protocol is going to be any, including TCP, UDP, ICMP. This is the single this is this IP address of server 2, so we can see that on like an SSHN. So these systems look almost identical. I'm going to flip over here to Foxtrot and SSHN as the Foxtrot user, server 2, into Papa 766. Log in, and just to verify, 33.54. I flip back over here to the Instructor Firewall. 192.168.33.54/32. So that looks good. And destination any. So any destination, any ports, any port ranges, or all port ranges rather. And then be sure to have a useful description here. So from BlueNet server 2, any protocol to anywhere. Let's say it's into any port. There we go. I'm going to go ahead and hit save on that. And need to turn it on. Click. Apply. Now I should be able to initiate my scans from server 2 back to my desktop and server systems. Let's go ahead and do that real quick. So that's it. Nmap. Disable ICMP if I'm not positive it's good to go. I just normally disable it anyway for scans. Aggressive scan of, I'm going to scan desktop. See, I'm doing this from my server 2 on Papa. So desktop Foxtrot 980, and then server 1 dot Foxtrot. Little command line trick there. Control K. Server 2.foxtrot.example.com. So this will scan all three. Should come back pretty quick if everything is working. Something's wrong. Let me go check my firewall. Hit apply. Yes. Check my firewall here. Oh, currently it's off, so everything is locked down on everything coming in from my WAN. So my firewall is semi-secure right now. So I'm going to go ahead and abort this. If I open these up, turn these on, then I should see all three systems come back pretty quick. Yep. Okay, there's desktop is 22 and port 3389 on desktop.foxtrot. and on server 1, just port 22, on server 2, just port 22. Now if I wanting to having the students, for example, secure this network as if it was going to be used as a actual enterprise network to say disable anyone from ever seeing my employees' desktop network systems, but probably going to allow them to access my servers down here at like a DMZ, then I would want to go ahead and turn off Blue Network 1, leave Blue Network 2, and if I get into more explicit rules, I would probably just do port 80 if I'm doing a web server 8443, but in this case I don't have it running, so I just have port 22, so I'll just leave Blue Network 1 inaccessible and keep Blue Network 2 accessible, since that's my server network, until I get a web server set up on them. I go ahead and applied that change, run the same scan again, and now desktop should be non-responsive, but my 2 servers will be responsive, so there we go. Scan 1,000 ports on desktop, got nothing, all filtered, and port 22 on server 1 and server 2 are both good to go. So that's a good example of how to use your system to teach students how to scan themselves. Once they set up their firewall, they'll need to be able to do this themselves. And then, as a final exam, you can deny them access or lock them out after they've done their setup, and then you scan their systems for a grade. So there's various things you can do here with this, but you can see how this is very useful and very much real world. The next lab we're going to do is going to take this a step further and actually installing installing Apache, like a LAMP stack, Apache here, MySQL here, setting up a database connection between the two, and securing that with the firewall. So we'll do that in the next lab. All right, so some things to communicate to students when you're doing this kind of training is, first of all, be sure, use the instructor, be sure your teachers already, or your students already have solid experience with TCP/IP, subnets, and site notation. Host names, as you can see how important host names are. Each system has a unique host name. Be sure you're looking at the right thing for what you're doing, what you're scanning, and what you're securing. Remember that your firewall rules are always based on the interface. So if you're wanting to secure things coming from the LAN, you click on that. If you're securing something, you want to secure your desktop system from your server 2, then you need to be clicking on Blue Network 2 to make sure that you're doing you want to secure this system, Blue Network 1, from Blue Network 2. Then in the firewall, you need to be working on traffic coming from Blue Network 2, not Blue Network 1. So where your traffic is coming from. You need to be aware of that. By default, team environments cannot see each other until you click the toggle Enter Team Connectivity button here. So just be aware when you first provision the system, no one can see anyone until you turn that on. So set up your courses and labs accordingly. For multi-student teams, only one person can access the Kali VM via RDP at a time. So like if you have a student team here that actually has 2 or 3 students in it, only one person can access the desktop at a time. If someone else tries to access the desktop at the same time, it'll boot the first user off. So it doesn't really pay attention to who's who. So typically, your firewall administrator will be the person logging into desktop server, the desktop system. And if other students want to use those tools like Nmap, for example, they can either do scans from down here, or if they want to do Metasploit, red teaming, they can SSH from here up into here and run Nmap like that. So just be aware of that. So hardening port scans can be done within an environment, but scans from other teams' VMs are recommended. So just what we said here, where if we're going to scan our systems, we need to be scanning it from outside our network, coming back in like we did here, as I showed you. All VM web traffic bound for the internet, like running apt packages upgrades, goes through the firewall. So if they've somehow locked themselves out from this traffic here, from getting to the firewall out to the internet, that could be a problem. By default, that traffic is allowed. And the important thing is established related traffic. So data flowing back from the web server, from the web back to the desktop, for example, is going to be allowed because it's established and related. It's tracking, it's doing stateful and packet inspection and tracking, saying, okay, this is a request to this website, here's the contents from this website, or here's a request to install a package using apt, using HTTPS, and this is the return traffic for HTTPS for that session. So that's on by default, so no worries there. But if it does happen where they lock themselves out, then they need to be able to get to the shell prompt on the firewall to do a restore. Okay. When logging in to the web UI, the firewall, you use firewall SSH credentials. So even though you're logging into the, for example, you're logging into this interface from the desktop system, you're actually logging in from using the SSH credentials. So I would click copy this password here, not this password up here. So even I'm logging in here, and then I'm pointing my web browser to the firewall and then using these credentials to log in. So an important concept to pass along to the students. Default configuration allows ICMP through to everything, so just be aware of that. Most firewalls by default will block everything and you just poke what you need, but we did open that up a little bit so you can start off at least pinging each other once the teacher turns on inter-team connectivity, which still has to be turned on, even to ping out between student systems and teams. All rules, firewall rules, are bound by interface or sorted by interface. Remember that. If you're going to affect incoming traffic, always operate on the WAN interface. All rules, unless manually changed, are first match top to bottom. So if you allow something higher up in a firewall rule, that's going to match and take precedence first, be allowed versus block. If you put a block at the bottom and you have an accept above it, the accept takes precedence because it's first match. That's how all ACLs typically work. All default rules or policies or catch-alls are set to block. So if it doesn't pass any other rule in a listing of firewall rules, then the last it's not shown rule is to block or drop the packets. So that's just a good firewall practice. So everything is blocked by default. You just poke the holes you want. That's all you need to remember. All return traffic we talked about is established related. If you're locked out of the firewall, again, use firewall SSH login, then sudo su to get the admin interface and the admin menu on the firewall. And never delete or disable firewall rules labeled do not remove. So let me show that real quick. Let's see how good firewall I already have up. Okay, so you see some rules say danger, don't do this, don't allow this. And here's some floating rules. You have auto-populated rules. I'm getting a little bit deeper here, but just to show you what I'm talking about. Access network, here we go. So this is the access network that CyberRange uses. So this is how the CyberRange gets into SSH into the systems and HTTP into the systems, and how it gets into the firewall. Do not remove these rules. If you remove these rules, then they're going to lock themselves out. This is what so an example I was giving earlier. If someone comes in here and deletes these rules, or even just disables them, then this interface we're looking at goes bye-bye. That's the case in which they would need to come in through the SSH and do a restore to the last previous state. Okay, I'm not going to click apply on that. I don't want to mess it up. Okay, so those one do not remove rules. Yeah, they can mess themselves up. Also, don't mess with the automatically generated rules. And finally, if you do have to reinstall the environment, for example, a student destroys their file system or gets hacked by another student because they left something open, then unfortunately the system, that entire environment seen here, that if they mess up this or mess up this to the point where it can't be repaired, then you need to reinstall this entire environment, which is like wiping all the hard drives and starting over. Now, unfortunately, when that happens, the host name is also going to change because it grabs the next environment that's available and issues it to that student. So the host name is going to change, which is going to mess up your spreadsheet. So encourage students, please try not to host your systems, but if they do get really messed up bad, then we can do a reinstall. And if you hadn't done that on the cyber range yet, it's just down here. There's a reset, which is like a poke it, power down, power it up, and then there's this which is a reinstall. So that's like a wipe all the hard drives and start over and give me new host names and IPs. So that really is like starting over. You don't want to do that. Students don't want to do that on an exam, or they're going to lose their work. So just be aware of that. And those are the big important things. If this video was useful to you, if you had any follow-up questions, just submit a support request here in the cyber range. You can go up here to click here and say, you can look at our knowledge base. We're gonna have some knowledge base articles on our shared networks environments. But customer support, so you'll submit a customer support request. Ask me if you need any help. I'm Tweaks. I'm kind of the current resident expert on this environment because I've helped steer its development, but our DevOps guys have done tons of work on this over the last couple of years, and our support folks are coming up to speed on it too. We have some knowledge base articles that are being published soon, and some really good labs that are coming out too. On my next section here, part 2 of the series is going to be hands-on lab demo of setting up Apache, MySQL, and securing the firewall and doing external scanning like we just did a second ago. So that's about it. If there are any questions, reach out to us and let us know. That's it. Take care and good luck.